Would that be true or false? You can't have mutually exclusive events and have joint probability, because mutually exclusive means they don't touch, they don't overlap. But if I were to ask you, are you in an accounting class, are you in an economics class, and are you in both? Those could overlap. You don't have to be in one or the other. Special rule multiplication. So we're going to get to a different type of calculation. These are two events that are independent, so they don't impact each other. These other events, if I drew a card from a deck and didn't put it back, it would impact the probability of the next time. So these are not going to impact each other. Two events A and B are independent if the occurrence has no effect on each other, so it's flipping the coin. And what I do to figure out the probability of both of those things happening, I multiply them by each other. So here's a survey of AAA revealed that 60% of its members made airline reservations last year. 2 members are selected at random. Since the number of AAA members is very large, we can assume that these are independent of each other. So this is going to be survey sample 1, sample 2. What's the probability that both made airline reservations last year? So I take this very slowly, step by step. I want to figure out what's the probability that the first person would make an airline reservation, and that's going to be 60%. What's the probability, and this is they're giving us this information, the probability that the second person would be 60% also. Now I have the AAA members are very large, assumed that they're independent. So to figure out what the probability would be for 2 people, the first 2 people I chose to get airline reservations, I would multiply the 2 probabilities together, and I would get 36%. Now, on the test, you can represent this as 36% or 0.36, but don't put 0.36% because that would be wrong. So another way to look at this, if it's a probability of 50% chance that you'll pass in this class, and I grab 2 of you random, what's the probability that both of you will pass? It would be 50% times 50%, so 25% chance that the 2 people that I pick would be both passing. Conditional probability means that one event is conditional on something else happening. So what's the probability that you will pass and make an A? Well, you have to pass to make an A. One's conditional on the other one. And this is how they are expressed, this symbol right here. Probability that A, given that B is going to happen. So the probability that I'll make an A, given that I've also passed. And the general rule of multiplication is used to find when these occur. And this is how it's represented. So the probability that I will both make an A and pass will be the probability of making an A times the probability of making an A and passing. So let's go through an example. A golfer has 12, I don't know why they always say if they get dressed in the dark. I mean, who grabs a shirt? I don't know. But the golfer has 12 shirts in the closet. Suppose 9 of the shirts are white, the other one they get dressed, they grab them in the dark, they don't know what they're grabbing. They do this 2 days in a row, they don't do the laundry, so they're not replacing anything. So the probabilities are impacted by one that's happening. So what's the probability that both of the shirts that I select are white? So it's, the second one's going to be the probability of this one being white given that the other one was white. So to break this down very easily, first I want the probability of the first one being white, W1. That's going to be 9 out of 12. What's the probability that the second one will be white? What is it? 8 out of 11, because remember I took one out already, and so that reduces the 9 and the 12. So now it's 8 out of 11.
Would you have to simplify that fraction? Or do we do this?
No, just leave it like that. Just multiply, yeah. And do this as decimals anyway. Just put 9 divided by 12 times, and if you have a graphing calculator, group it. If not, it'll do it on its own. And then I just multiply. So it's going to be the 9 twelfths times 8 elevenths, and it would be 55% chance that if I reach in there randomly 2 days in a row, and I had 9 to start with, that I would have white shirts both days. Those are the type of problems you'll get. Sometimes when you read the homework, it's very congested with verbiage and numbers that you may not need. So refer back to these examples and break it down simply. They're wanting to know what's the probability that you would call in this month and call in this year, whatever it may be. Break it down simply by looking at these examples. It's much easier. A contingency table is that table that we had set up in all these problems. It's just putting the probability in a table form. So here I have 150 adults classified by their gender and the number of movies they attended last month. So I'm able to categorize everybody. And now I have all this information. I have a total of 150 people. I know how many men I have, how many women I have. Those should add up to 150. I know how many people attended 0, 1, and 2 movies. Again, those should add up to 150. So now I can, if I was to give you this table and a problem, I could ask you a variety of questions. So what they've gone in here and done, and again, put this as an L or something. This one's going to be, I don't know why I did the same example, but this is a length of service and loyalty to a company. And they've just given you this data. Use whatever letters it's going to help you to keep it straight. A sample of executives were surveyed about their loyalty to the company. If they were given an offer by another company, would they leave? They were to rank that. And then they have 200 executives, and they also rank how long they've been there. So would remain, would not remain, and then classified to how many years they've been there. So what is the probability of randomly selecting somebody who is loyal to the company, so would remain, and who's been there more than 10 years? So where these intersect. So the probability an executive will remain with the company despite an equal or slightly better offer. Again, information you don't need. You just want to know, just give you the nuts and bolts. I want to know how many would leave or how many would not leave. Since there are 120 executives on the survey, it'd be 120 out of 200. So I go back. There were 200 total. They want to know each one of these probabilities talks about out of the total, not out of the men or the women or less than 1 year, whatever it may be. They want to know the total. So who would remain, executives who would remain would be 120 out of 200. That's the first category I want to deal with. The next one would be, what's the probability of it being randomly selecting an executive with more than 10 years? And then the conditional probability, of course, would be that given that they have also decided they're going to stay. So that's going to be 75 out of 120. So let's go back at it here. And I have the would remain would be 75 out of the 120. So this is where they're getting the numbers from. Out of those that would remain, and this is how many have been there for more than 10 years. That's what they're asking for, 10 years or more of service. So then I take both of those probabilities. I think in a table it's a little bit easier to read. I take both of those probabilities and multiply them by each other. Again, you can multiply straight across, or you can just do this in a calculator. It's much easier. And then I get 37.5% chance that if I randomly selected somebody, that they had been there more than 10 years and they would be more likely to stay with the company. Contingency tables are a little bit easier, at least to me, to read, to figure out this probability. Just remember when you're reading these, if they're talking about would remain, it's going to be out of the total that would remain, not this total 200. That's why we're going to go through some problems. And then tree diagrams. A tree diagram is useful for portraying conditional and joint probabilities. It's just a graphical way to represent something happening. Now the example that they give you, this one can be kind of confusing. What they've done is split up the probabilities. To me the table is much easier, but I'm going to go through an example where the probabilities are even. I have 120 out of 200, 80 out of 200. So that means these that are all split up are going to be out of 120, because remember that's the 120. All of these will be out of 80. So it's just putting all these into a table, taking them out of the table and putting them in there. Let me see if I can get this to work really quick, and let's go through an example. Oh my goodness. Okay, we'll do this in a minute. I can't get it to work some days, get it work the other days. I'll go through a tree diagram example in a minute. Bayes' theorem. Okay. You need to know what this is. It's a method for revising the probability given additional information. You will have a problem on there, and looking at this, it's very overwhelming, but look at each chunk by itself. This is the probability. This is that general rule multiplication. The probability of AI happening, the probability of B happening given that AI has happened, so, or A1 or AJ or whatever it is. So that's what all of these are. The probability of one happening given that something else has happened. So break these into 3 separate problems and then plug in the answer. If you try to do it all in this one formula, you can get kind of confused. So here's an example. They've given you this information. These are different electronic manufacturers, microchip manufacturers, and this is the percent of the chips that are defective. So they've given you this information. This is the probability that's purchased from Hall, from Schuler, and from Crawford, from each one of these different manufacturers. The probabilities are given here. The probability that this one manufactures it, this one manufactures it, and this one manufactures it. All these add up to 100. This is the probability that they're either defective or not defective. And they've given you these in the problem. And this is just, nothing has been calculated. All it is just writing it from the problem. The probability that it is from Hall Electronics and it's defective is 3%. The probability that it is from Schuler Electronics and it's defective is 5%. And then Crawford and defective is 4%. This was given to you in the problem. If you write it out like this, then when I have to plug it into the formula, I can do it very easily. So now I have a selected chip at random because the chips are not identified. I don't know who's manufactured them. What's the probability that the defective chip will be from Schuler Sales? So the probability that the one I pick will be one of the defective ones from there. And easiest way to set it up is in these contingency tables. I have the probability of it being from these three manufacturers here. The probability given that they're defective from each one of these manufacturers. And the joint probability, these multiplied by each other. This tells me this joint probability. This is adding these all up would be the probability of it being B1. And then I come up with these probabilities right here, the 0.009, each one of these times this 0.039. And it tells me the probability of this one, and this one. Which one am I looking for? I think it tells me. I don't know. Schuler, so it's going to be this right here, the 2564. You may have one problem like this on the test. You may have one problem like this on the homework. This isn't necessarily where I'm concentrating though. And I'm definitely not going to have, I'll have you doing a tree diagram, but I have a very simple tree diagram which I'm going to go through. So if I'm plugging this into the formula, I have 0.2 times 0.05. This is the probability of it being the A2 and being defective. And then they've just plugged these in for each one of the manufacturers. Another way of calculating it. I think that it's easier to calculate like this than to put in this table, or I think it's way more confusing to do this. But some people just think like that, and that's okay. Multiplication formula, and this is going to be, you're given the algebra problems from 8th grade. I have 5 ties and 3 shirts. How many different combinations can I come up with? This is the same type of formula or problems, but I have 2 different formulas to do. Multiplication formula indicates that if there are m ways of doing something and n ways of doing something, then there are m times n ways of doing both. If I have 10 shirts, 8 ties, how many would I have? Theoretically, it'd be 80. So here I have 3 different types of cars, 3 different types of colors, or 2 different types of cars, sorry, and 3 different types of colors, or whatever it is. 4-door model, different tires and such, whatever they're looking for. So there are 3 different arrangements, 2 different combinations. There would be 6 different ways that I could combine these to make these cars. Permutation is any arrangement of R objects for n possible objects. This is the formula I'm going to use. Who knows what this little exclamation point means? This is algebra.
You always just square it all the way down, something like that, right?
Multiplied, close, yeah. Very good, okay. So what I do if I have 5 factorial, that's factorial. 5 exclamation points can be 5 times 4 times 3 times 2 times 1. Yeah. So I know, you're like, I haven't thought about that in forever. Combination formula, it's almost the exact same formula. It's just I have this extra R on the outside. So my number changes a little bit. So these are 2 different formulas. This is the one where order doesn't matter. I just want to know the top 5 students in my class. This one, order does matter. I want to know in order who those top 5 are. So let's go through an example. I have 12 players on our basketball team. The coach must pick the 5 players among the 12 who would be the starting lineup. How many different groups are there? This is going to be the one, again, where this will be where order